Hey everyone. So glad to be with you. If you do not know who I am, my name is Shannon Keebler and I'm the moderator of our Facebook group. And I know some of you are joining us here on our website, www.empowerlearngrow.com. We're so glad to have you. So we are learning tonight about the math expressions subtraction strategies. And a couple of weeks ago, we talked about the math expressions addition strategies and how we might use the visual quantities, what the difference was with an algorithm, a standard algorithm. What does that definition actually mean in the standards? And so we're going to connect it tonight to how this all pans out in subtraction. Now, subtraction tends to be the evil stepchild, if you will, right? So it's the one that students have the hardest time with. It's the one that a lot of our teachers have a hard time with. And so I want to connect all the subtraction algorithms tonight and hopefully give you some strategies that are going to allow you to teach those strategies more effectively. So let's talk about a couple things. One is this actually starts in kindergarten. When we start to introduce subtraction, our kindergarten students are first just learning what subtraction even is. Like, what does it mean to take something away? So every time we take something away, we're using that minus sign because part of this kindergarten world is just figuring out what symbol do we use to represent that action? And they oftentimes get the symbols of the plus and the minus sign mixed up. So we're going to do TPR, total physical response. We're going to do all the things to help students to know when we're going to subtract. But also for a lot of our Ks, subtraction just means things go away. And that is one definition of subtraction. But another definition of subtraction is just the missing partner. So we know with the Math Mountain that we have a partner, and total, and we say, well, total at the top. So it could mean that we have a total and we take something away, but then we're still left with this unknown partner. And we really want, starting in kindergarten, for kids to know that there's both things that exist. Yes, subtraction can mean actually putting down fingers or taking things away, but subtraction can also be just very simply the missing partner, the unknown addend. And if we don't really understand that connection, then subtraction becomes really, really difficult. Because as we get into second grade and we start having teen subtraction, kids start running out of fingers and toes. It cannot just mean to take things away or to count backwards. In fact, that strategy becomes extremely ineffective or inefficient, both of them really, right? And so we start to teach some of these algorithms to help students now take things away, but we always connect it back to the unknown addend. So even in kindergarten, what I want you to notice here is that the minus sign is always going to mean to subtract. So in kindergarten, when we have something like 3 apples and we take something away, when we take something away, we don't X it out, we don't erase it, we subtract it, and we subtract it specifically by using the minus sign. We are trying to give that reinforcement over and over and over again that subtraction is a minus sign. It goes away. This also tells the whole story. So we don't erase things because we want to be able to see what we started with. Now, this is going to grow as I get into second grade, third grade, fourth grade, fifth grade, when we're doing fractions and decimals. I'm going to connect all of that for you tonight. But the first thing we want to remember is that the minus sign means to subtract. So as we go here and we go into some of these strategies, let's take a look really quickly into the first one. So we first do ungroup everything. Now, in kindergarten and first grade, it's as simple as we're just doing ones and maybe tens drawings, and we're using a minus sign to take things away. We start, though, to formalize it and put them into algorithms because we start to get much larger numbers. So right now, we're not necessarily talking about fact fluency, like that simple subtraction. We're talking about what happens now when we get into more sophisticated numbers, 3-digit, 2-digit, 3-digit numbers, where now we have something called ungrouping. And the standard is very clear that students starting in second grade have to know when it is necessary to either break a number apart, decompose on tens or hundreds, to get more ones and tens, or when we might have enough ones and tens to compose and make a new group. So when we talked about addition, we talked about the idea of composing. When we're talking about subtraction, we're saying, now how do we decompose a number so that we can actually subtract the amount we need? In expressions, we're going to use the word ungroup and we're going to use the word regroup. You and I talked about borrowing and trading, and we use a lot of those words growing up. We're going to use the actual term, which is more accurate. It's ungrouping something. So in addition, we were regrouping. We had enough ones and we made a new group of 10. And in subtraction, we're now going to ungroup. So let's take a look here at ungroup everything. We're actually going to start with that expanded form, which is exactly what we started with when we were in addition. And so if I use, let me see a problem here. We have 365 and we're going to subtract 189. So if I have the number 189 and I subtract 365, now there's a few things that's going to happen. First of all, with 365, I'm going to draw a magnifying glass around it. And this is an expression strategy because I want kids to clue into that top number. I only want them looking at the top number because you and I both know one of the common mistakes is if they have 5 and they have to take away 9, they're like, wait a minute, we can't do that. So then like, no problem. We'll just take 9 and we'll subtract 5. And they go from the bottom to the top. So we circle that top number to say that is the only number you have. So let's connect it now to that unknown add-in idea. If I have a math mountain, I would say, where do these numbers go on the math mountain? And this is the work of kindergarten and first grade. And they should say that this is the total, this is a partner, this is the unknown partner. And a lot of kids don't think that because if I have 365 and I subtract 189, so although I just stacked the numbers for you, for students, I always write them horizontally because one of the hardships is figuring out, number one, how to stack them correctly when they go to do an algorithm, but also I want them to see the relationship of those numbers and then I want them to know what we're finding. And for a lot of students, they think this is still partner, partner, total. Not the case. This is the total, this is a partner, this is the unknown partner. So in this case, I could say, take this number, this equation, and put it on the math mountain. It is one of the very first things I have kids do, no matter their grade. 5th grade, it does not matter. Put it on a math mountain. When they put it on a math mountain, they see the relationship and they start to think a little bit more open-ended. Like maybe I could just do adding up. Maybe adding up is a more efficient strategy than subtracting, especially when I have double zeros. So in this case, I would put 365 and I'd say, well, one of my partners is 189 and I'm looking for my unknown partner. So the first learn, can't I just add up? Now, my first grade teachers used to be thinking, wait a minute, we do that. And I'm like, yeah, you do. You have 8, you have a partner of 5, and you're saying, what's the unknown partner? First graders learn they can just do 5, 6, 8. They counted up 3 more. My unknown partner is 3. That is the second definition of subtraction. It's just the unknown partner versus kids putting up 8 fingers, putting down 5 and saying, well, I actually had to take something away and now they have to count their extra fingers, which would be 3. That, of course, is a significant definition of subtraction. It's important. But again, as those numbers grow, it is no longer efficient to put down 189 fingers, right? So what if I added up to get this? And again, this helps students see what is the friendliness of those numbers. Because what if, let's just say I had the number 400 and I had something like 389? Well, why would I stack those numbers? Why would I do that to myself and ungroup over double zeros? Like, raise your hand if you're good at that. Put your hand down. No, you're not. It is so difficult. No one's good at that because it's unreasonable. So in this case, I'm thinking, what if I just added 1 more and I got to 390, and then I added 10 more and I got to 400, running out of space. Sorry about that. And I say, well, look, all I did was add 11. Those numbers are so friendly. I should probably just count on. So in 2nd grade, that is one of the main strategies. 1st grade, you do it too. You talk about counting on to find the unknown add-in. 2nd grade does the same thing. They first introduce it as adding up or counting on. So we're going to go ahead and take these ones away, but just remember that we should always have students think about what is the relationship of those numbers first before we go into now a more standard algorithm. So this strategy right now, as we go into expanded, is not actually considered a standard algorithm because it's not generalizable with larger numbers. It doesn't really come down to a single digit computation, but it does help students to see what is happening. So in this case, I'm going to take 300 plus 60 plus 5. I'm going to expand the number. I'm going to expand the bottom number, 100 plus 80 plus 9. Okay. And now when I go to subtract, I see the whole number versus I subtract here, I cross off the 3, I put a 2. I'm hoping we have place value understanding and we know that's a 200, it's not a 2. Or the kid that just puts a 1 right here and he says, now that's 16. I'm like, sunshine, that's not a 1, that's a 6, that's a 10. We now have 16. So for kids that are still growing number sense and place value understanding, the expanded is a really nice stepping stone because remember, second graders do not have to have a standard algorithm. They just have to have one numeric method. The expanded method counts. Now, we're going to grow that into some of these standard algorithms and give them as options. But if their place value understanding starts to fall apart because you've now proceduralized it, you're going to take them back. Okay. So here I have this. So this is the expanded where I really stretch it out. So let's go over to our drawing because that's really where students now learn the fullness of the standard of understanding when we have to decompose to get more of a certain number. So I have my circled here. I have 365. I'm going to draw 360. I always do a 5 group and extra and ones, 5 ones. Now I don't draw the second number. I don't have the second number. Remember my math mountain? I don't have 189. 189 has to come from my 365. So I only draw 365. Now I look at it and I start to do some of these other methods. So the first one could be ungroup everything. That's one of the methods. If I ungroup everything, I can ungroup everything from the left to the right. I can ungroup everything from the right to the left, and then I can decide to subtract. So let's try ungroup everything from the left to the right. So I would say, okay, let's just ungroup everything. I'm going to ungroup 100, and now I'm going to use an X. A minus means to subtract. An X means to ungroup, because I should be able to look at their proof drawing and know what is the difference. Okay, so what did you ungroup versus what did you subtract? So I ungrouped 100, and when I ungroup 100, I get 10 tens. Now I can ungroup a 10, and I would get 10 ones. That's ungroup everything. Let's just go ahead and make our life simple, and let's just go ungroup everything. Even if we don't need it, we can just ungroup it all. Okay, or I can go place by place and say, do I need to ungroup? Yes or no. Do I need to ungroup? Yes or no. But that's going from the left to the right. Now I could repeat it. I could say, well, I have 5 ones. I have to take away 9. I don't have enough ones ungrouped. So I'm going to go next door. I'm going to ungroup a 10. I'm going to get 10 ones. That's going from the right to the left. Now, how do I subtract? Well, I can ungroup everything and now just do all the subtraction at once. Or I can ungroup the hundreds, do that subtraction. Ungroup the tens, do that subtraction. Ungroup the ones, do that subtraction. So let's do our ungroup everything. So in this case, I ungrouped the 300s, and now I had 200s. If I do it and expand it, I see the whole number. I ungrouped, so I don't have 300s. Now I only have 200s, because look, I only have 200s over here. And I gave that 100 over here to the 60, which means now I have 160. Look, I have 160 right here. Then I ungrouped the 160 because I ungrouped one of those 10s. And instead of 16, now I have 15 tens because I gave that 10 over to my ones. I don't have 5 ones. I have 15 ones. I can do the same here. I ungrouped the hundreds. Now I only have 200s. I gave 100 to my 6 tens, which means that was 10 tens. So now I have 16, and I prefer them just to rewrite the number, up to you, 16 tens. Then I ungrouped one of those 10s, which meant I only had 15 tens, and I gave it to the 5, and now I have 15 ones. All of that is provable over here, but my language matters. So if I were to do it step by step, which most second graders prefer, they just prefer to do it step by step. Ungroup the 10, then ungroup the hundreds, and they go one by one. So now let's do our subtraction. Because I did my ungrouping, I can subtract left to right or right to left. Students that are dyslexic, students that struggle with dysgraphia, students that struggle with reading in general, they read left to right. They can do all math from the left to the right. So in this case, I ungrouped everything. I may have done work I didn't have to do, which is the down part of doing that, but I did ungroup it all. Now I can say 200s minus 100, subtract 100. How many do I have? I have 100 left. 200s minus 100 means I have 100 left. 15 tens minus 8 tens is 7 tens. 15 tens minus 7 tens equals, oh, did I just say that right? 15 tens minus 8 tens, there we go, means I now have 7 tens. 1, 2, 5, I have 70 or 7 tens. 15 ones minus 9 ones, so let's just take away 9 right away. Notice it's a minus sign, means I have 6 ones left over. Did I just do my math right? There we go. Okay, so now I have 1, 2, 5 worked. My answer is 176. My answer over here is 176. 200 minus 100 equals 1. 100 minus 80 equals 70. And 15 minus 9 equals 6. So I have 176. So all my answers match. Now, could I have gone from the right to the left? Sure thing. 15 minus 9 equals 6. Took that away first. 15 minus 8, do you see? I can go from the left to the right or the right to the left. I can use it with expanded, or I can ungroup everything, or I can ungroup one at a time. So if I were to ungroup one at a time, I would have said, well, 5, take away 9, and I'm not going to say I can't do it. Okay, so I want to let everyone hear that one more time. I'm not saying I can't do it. You're saying you have 365 M&Ms and you can't give me 9? That's a number sense issue. Yes, you can. You can give me 9. The problem is they're not ungrouped. The problem is they're grouped in that 10 over there. I have to ungroup to get them. So I'm pretty specific about that. Please don't tell me you don't have enough. You don't have enough ungrouped. So now when I say I have 365 and I subtract, sorry about the handwriting here with the mouse, 189. Okay, I say 5 minus 9. So I have my 5 ones here. I magnifying glassed it, right? So I have my 6 tens, excuse me, and I have my 300s. Now I say I have 5 ones, take away 9. They're like, oh, there, I have to ungroup. I ungrouped a 10, and now I got 10 ones. Okay, so now I can say I ungrouped a 10, which now I only have 5 tens, and now I have 15 ones, and 15 minus 9 equals 6. Take away my 9. Let's see if it's true. 5, 6. So now I'm going step by step. I ungroup it, I subtract it. I ungroup it, I subtract it. So those are really the 2 main strategies, is you can ungroup everything from left to right, or you can ungroup everything from right to left and then do all your subtraction at once, either left to right or right to left. Or you can ungroup one step at a time from the right to the left. Ungroup to see if I need any ones, do that subtraction. Ungroup with my 10s, do that subtraction. Ungroup with my 100s, then do that subtraction. So we share those methods with students, and then they get to choose which way does their brain do better with chunking. Students who have IEPs, students that struggle with multi-step, they actually do better when you chunk the steps, when you do all the ungrouping at once, and then you do all the subtracting, versus going back and forth, and then they have to remember, what was I supposed to do now? And that's when we start to see mistakes in them going from the bottom to the top. We start to see subtraction mistakes. They don't have the place value language. So that's when chunking becomes really helpful for all students. Okay, so now take a look at what happens when, so we talked about a few of these. We did ungroup everything with expanded, ungroup everything regular, ungroup right to left, ungroup left to right, and then we did talk about just the expanded. So what would happen if I did it with decimals and fractions? Okay, if I did it with decimals and fractions, the exact same idea. So what if I said 46 hundredths? Okay, so I say I have 46 hundredths and I need to subtract 29 hundredths. Well, again, I'm going to do a variable because I'm in the upper grades. I'm going to put it on a math mountain. What is the partners? What is the total? I'm like, well, the total is 46 hundredths. One of the partners is 29. I'm looking for hundredths. I'm looking for an unknown partner. Couldn't I just add up? Yes. Isn't that the mental math most of us do? When you're sitting in the grocery store and, I mean, nothing really costs as much these days, but you have 46 cents and you have to take 29 cents. You don't actually do subtraction in your head. You add up. in your head. You kind of make change by counting back. That is the most common subtraction that we do. I want students to continue to think about this flexibly. Then I want them to think, well, I also need you to understand ungrouping and regrouping, which is the standard, but you have to have a visual method. Fourth and fifth grade, adding and subtracting decimals says based on concrete models. Okay, so in this case, I'm going to do 46. I'm going to do it with money. So 46 hundredths means that I have 4 dimes. Okay, and I could mark all those as dimes, and I have 6 pennies. And I could put a P in every single one to know that we have pennies. Now, I have a magnifying glass. That's the only number I have. The strategy did not change. So I show my fifth graders, you did this in second grade. We do a double-digit problem. Do you remember doing this? Ungrouping a 10, getting 10 ones? Like, yeah, I remember. It hasn't changed. Okay, so now, though, we have tenths and hundredths. If I had holes, let's say I added 4 holes here, I would draw $4 bills. It's the same idea. If I ungrouped a dollar bill, I would get 10 dimes. Okay, so in this case, I have 6 pennies and I have to take away 9 pennies. So I don't have 9 pennies here. I am going to ungroup. I'm going to ungroup a dime. And if I ungroup a dime, I get 10 pennies, which is 10 hundredths. So now I have enough. I ungrouped the dimes. I only have 3 dimes now. And I gave a dime to the pennies, which now means I have 16 pennies. 16 pennies minus 9. You can see I have 7 pennies left. 16 minus 9 equals 7, but it's not 7. It's 7 pennies. It's 7 hundredths. Now I have 3 tenths, 3 dimes, and I have to take away 2. I'm going to subtract 2 using my minus sign. I have 1 dime left, which is 1/10. My answer is 17 hundredths because I don't really have those $4. Okay, so now I have 17 hundredths. It worked the exact same way. When I ungroup a penny, I get 10 thousandths. Now I do pie pieces because we know that's 1/10 of a penny. We don't actually have a coin that size. So we draw it like a little triangle, which is how math expression shows it. Okay, look, it's the same thing, friends. So now when I go to fractions, nothing changes. Okay, so take a look. So if you're in first grade, second grade, third grade, you're like, do we really have to do it this way? Can't we just have them do a diagonal for subtraction? Can't I just have them do an X for subtraction? No, you cannot, because this doesn't change. It doesn't stop. It doesn't go away. So fourth and fifth grade teachers, your job is to connect it. This is not anything new. It's still ungrouping. So let's just say that I have something like 2 7/5, and I'm going to take away 1 2/5. Okay, simple problem. Now, I'm not going to do any common or uncommon denominators, but I could, and I could do a picture for that. If you're in the Math Genius Squad, there's a video that shows you. I'm going to do the exact same thing, but now in order to find a common denominator, I'm going to have to change my picture just a little bit to show you I can find a common denominator without even knowing my multiplication facts. I can do in splitting with my picture. Not going to go over that tonight, but you can see the same idea. Look it goes on a math mountain. What do I have? I have 2 7/5. I'm taking 1 2/5. So now I know I'm looking for an unknown partner. Now I'm going to come over here and I'd say, let's just go ahead and stack it now. Now I know, but look, couldn't you just count up? I mean, come on, friends. Why would we not just count up for this? I know that I need 3 more fifths, right, to get to 2. And then I need 7/5 to get to 2 7/5. Why would I not just add in my 3/5 and my 7/5 to get my answer? Like, why would I not just count up? Okay, counting up in this example makes way more sense than doing what I'm about to do. But this is the conceptual piece. So I'm going to go ahead and subtract 1 2/5. Okay, and now I have 2 wholes. So this is what I have. I have a part. I have 7/5. Oh, my friends, of course I did something like this. Let's just change this to 3. Let's do 3/5. Okay, so I need something like 1/5. That makes more sense. Okay, so now I have 2 1/5 minus 1 2/5. Now we have a good problem. So 2 1/5. So I'm going to go ahead and make this into fifths, which ask me why I chose fifths. I don't know. So there's 1/5. Now I have 2 1/5. Okay, everyone see it. That's what I have. I have to subtract 2/5. Okay, so if I'm going to subtract 2/5 here, now I'm going to say, well, I don't have 2/5. So I'm going to ungroup a whole and I'm going to get 5/5. 2, 3, 4, 5. Okay, and I now have 5/5. So I have 5/5 plus 1/5, which means I have 6/5. So let's look over here. I ungrouped a whole, which now means I only have one whole, and I gave 5/5 over here. So now I have 5/5 plus 1/5, which means I now have 6/5. So I have 6/5, and now I can take away 2/5. So let's take away 2/5. I'll take them one here and one here. Now I have 4/5 remaining. Now I have 1 minus 1. Take it away. My answer left is 4/5. So if I look over here, I have 1 and 2/5. Yes, 1 and 2/5, and I have to count up to get to 1/5. That's why earlier my example was not working in my favor. Lots of extra work there. Okay, so now I have 1 and 2/5, and I had to add 3/5 to get to 2. Okay, so if I added this, I would now have gotten to 2. Then I have to add another 1/5 to get to 2 and 1/5. So now 3/5 plus 1/5 would equal 4/5. It's the same answer. So counting up would have been just as easy as ungrouping, but we know that in the 5th grade standard, ungrouping is an important part of the standard, knowing when to decompose a whole number to get fractions, unit fractions, to be able to subtract. All right, you can start to see that what we start in kindergarten never goes away. We're ungrouping, we're regrouping, we're using X's for ungrouping, we're using a minus for subtracting, and then my language matters. I have enough. The problem is it's grouped. I have to ungroup it. I'm ungrouping a 10, I get 10 ones. We do it in our numeric method, we do it in our picture. We do it in our picture, we do it in our numeric method. Once we have that set, we can do all. I can do all the picture and just do that and just see if it works. Then do my numeric method, do that all at once, and then compare my answers. That means I use it as a proof picture. I proved that my numeric method worked. In the beginning, we teach them side by side. You do it here, you do it there, so students can get the right language. All right, my friends, what's on your mind? What questions do you have? Let me know below. Remember, if you're matching your squad members, there's videos for whatever numbers you work with, whatever size, 4th grade, 3rd grade, does not matter. Remember that your standard algorithm does not mean the shortcut. Okay, standard means generalizable based on single digit operations. So any of the methods I showed you, other than the expanded, count. Ungroup everything, ungroup left to right, ungroup right to left, subtract, all of those work to meet that algorithm standard. And the proof picture meets the based on place value using concrete methods. All right, my friends, thanks for joining me. So glad that you came, and we'll see you next week. Bye for now.